The purpose of this lesson is to learn how to declare arrays and assign values as elements, how to access the array elements, how to search through an array using a loop, how to use the binary search, sort, and reverse methods, how to use multi-dimensional arrays, and about issues that arise when you introduce an array into a GUI program. A variable only allows us to hold one value for the named memory location. An array is a named memory location that allows us to have multiple values. Now, an array is going to be a list of items that all have the same data type, and then we simply reference them by an index number. So what we have to do is we have to declare a memory space, and the way that we declare that what we're creating is an array is after our data type here for double, we include a set of square brackets, and then we give it a name. So the name of our array in this case is going to be sales. It's going to be an array that contains double values. So all of the values contained within the array are going to be doubles. Then the next thing that we do is we take our sales array that we just created and set it equal to a new double of a certain size. So essentially what we're doing is we're creating a memory location, and then the next step is we give it a size. So we tell it how many values are going to be contained within this array. The new operator is designed to create new objects. We will get more into objects in a later lesson. But for now, you just need to be aware that you have to create a new double location or a new array location and set its size so that you can actually add elements to it. If you don't set the size, we can't add elements. We can change the size of the array later, but unlike some programming languages, we have to go through some extra steps to be able to change the size. An array has elements, and elements are just simply going to be each of the values that are contained within it. And each value is referenced by a subscript or an index. And the subscript in C# will be an integer value starting at 0, and then each value will be one number higher. So my numbers are going to be 0, 1, 2, 3, 4, and so forth. So if I were to tell you that an array holds 5 elements, the first element is going to be 0. The last element is going to be the size of the array minus 1. So it would be 0, 1, 2, 3, 4. That's 5 elements, but you have to account for the fact that we start at 0. We don't start by 1. So when you're designing programs to work around these arrays, you'll encounter what's called a one-off error, off by 1 error. And essentially what that means is that you forgot that you started at 0 and that the last element is not the length of the array, not the number of elements. It's one less than the number of elements. So when we declare an array, what we're doing is we're taking one great big contiguous chunk of memory, and we're simply breaking it up into smaller pieces, and we give them numbers or an index to identify each piece. So in this case, we have our sales array that has 20 items in it. It starts at an index of 0 and goes all the way down through an index of 19. So 0 is our beginning, 19 is our end. So 0 through 19 is 20 elements. Notice that there are 20 elements in it. Our highest number is one less than our size. So to assign values to these array elements, what we're going to do is specify the name of the array and then the index, and then the next thing is what value we're going to set it equal to. So remember, it always works out to be whatever the value is on the right side, we're going to put that into the value on the left side of the equal sign. Remember, this is our assignment operator. So if I wanted to print out the element value, then what I could do is just simply console.writeLine and specify sales and then item number 19, and that will print to the screen the element or the value of the highest element. All right, so in C#, arrays are objects, which means that we can play with them as if they were a class of objects. We can actually use other methods against them. What happens is when we create the array originally, we set a size. What it will do is it will automatically make an array with all of the elements in it, and every element is set to null. Null actually does have a value in the system, which is a \u and then 4 zeros. Now, even though this is a value, this is a specific delimiter designed to tell the system that this value is null. So when I first declare the array, all of the values are null until I actually assign them to something else. So I want to provide a way to make an array without necessarily having to go through and do sales 0 is equal to this, sales 1 is equal to this, sales 2 is equal to this, and so forth. There are shortcut ways to actually create the array, and what we're going to do is we're going to use what's called an initializer list. And there are different ways you can do it. Some of them are faster, but I want to show you the different ones. So in this case, we're going to create an array that contains integer data type. We're going to call it myScores, and we're going to set it equal to a new integer. And what we're doing is we're specifying the size of the array. So we're going to tell it there were 5 elements. And then inside of a set of curly brackets, we actually put all of the elements, and each one is separated by a comma. We could simply do this exact same line without specifying the size, and the system will automatically know the size for it. Or we can even go shorter than this. We don't necessarily have to specify the new. It will allow us to do our integer array, call it myScores, and set it equal to all of the values. And it will automatically know that the size is 5. Now what happens is when I do this, if I specify the size of the array, if I were to state that this is 10, I could provide just the first 5 elements and it would allow me to add 5 later. If I go with the shortcut version, the size of the array is 5 and I cannot add more without doing some other things programmatically. Alright, so the question is, why are we going to use arrays? And the answer is, if I were to ask you to create a program that would ask a user to input grades, and we don't necessarily know how many grades they're going to enter, what you'll end up with something like would be like input grade 1, and then we'd have a variable called grade 1, and then we ask them to put the value into it. And then we need grade 2, put the value into grade 2. We need grade 3. Well, the question is, how many grades do we really need? And we don't necessarily know. But if I'm using variables, I would have to make 100 different variables to hold up to 100 possible grades that the person could enter. So 2 things. One, I'm wasting space because I'm creating variables which are memory locations. So I'm wasting memory for things that may not necessarily actually get used. And on top of it, I'm also providing an artificial limit. And the artificial limit is simply stating that you can't have any more than 100 grades, or however many variables I created. With an array, I can create an indefinite amount of values. So if the user wants to enter 500 grades, they can just simply keep re-entering grades. Now, in other programming languages, and if you've ever used Raptor before, a lot of those will allow you to just simply add a new value and it'll keep increasing the size of the array by 1. In C# you can't do that. We have to manually do it. Alright, so what I can do is I can go through my array and I can use a loop to pull data out of the array. So in this case, what we can do is we can reference the index or the sub, we can reference that as a variable. So in this case, what we're doing is we're creating a for loop with a counter called sub, and we start it at 0. While sub is less than 5, we're going to increment the sub by 1. So while it's less than 5, we're going to do this, then we increment sub by 1, and then we keep doing it 5 times. Alright, so what would happen is the first time we go through, it would be looking at the value for myScores sub, which is 0, and this means to add 3 to whatever the value is in there already. Alright, so then we increase sub by 1, so now sub is 1. Now we're going to look at myScores 1 and set its value to 3 more than what it is now. Increase sub by 1, now sub is 2. Now we're looking at myScores 2, and so forth. So what happens is I now have the ability to reference multiple variable locations, the elements in the array, inside of a loop. I don't have to ask the user, what's grade 1, enter grade 1. What's grade 2, enter grade 2. I can actually put that in a loop, and within just a couple of lines of code, I can reference all of the memory locations that are used for the array. Alright, so every array is going to have a length, and the length is just simply going to be how many elements are in it. So if I have an array with 5 elements, its length is 5, and its highest value would be 4. I'm sorry, its highest element would be 4. So keep that in mind when we're playing with the arrays. Our highest element index is always going to be 1 less than the length. But what I can do is I can actually get the length of an array. So I have the option of looking at my array and its .length property to see how many elements are in the array. So what I can do is I can form a loop that just simply says start at 0, perform this loop the number of items that are in the array, and then it'll just simply go from the beginning to the end of the array. I don't have to know how many elements are in there. It'll automatically do that for me. I can also use what's called a for each statement. Now, a for each statement is the same thing as using a for loop and incrementing by 1, but essentially what this one does is it creates a temporary variable location. And I say variable, but be careful with that. It's called an iteration variable. And what that means is that it's going to create a temporary variable that I cannot change the value of it. The system does it when it reads it out of the array. So what it's going to do is it's going to create a variable to hold the value of each of these elements that are in our array. And so what we're doing is we're telling it for each, and the data type is a double. We're going to call this temporary variable money that is in the pay rate array. And then what we can do is we can actually manipulate that, where we could say console.writeLine, and then we're going to write out money, which is this value, to a currency string. All right, so what this does for me is this will automatically go through the array. It's like using a for loop, initializing a counter, going up to the length of the array, and incrementing by 1. It does that automatically for me. It doesn't matter if you want to use the for each or the for loop. A for each is just a little bit shorter, but I also have one extra benefit, which is it creates a temporary variable location to hold the value that is in the array. All right, so when I want to access every single element, we're going to use a for each. If I don't necessarily want every single element, then a for each won't work, because it actually will go through every single element that's in the array and it will perform that function for it. All right, so we can use this for each for enumerations also. Now this gets a little confusing when you first look at it, but what I'm doing is I'm going to say I have an enumeration called day, notice the capital D, and it has all the days of the week in it. Remember, our enumeration goes outside of our main method. And so I'm going to do for each, and the type of data that I'm looking for are strings, and I'm providing a variable name. So what it will do is our iteration variable, as it pulls each thing out of the enumeration, it's going to stick the value into day. And where is it getting the value from? Well, it's getting the value in the enumeration, and there is a method called getNames. And we will talk more about methods and procedures in a future lesson. But for right now, just be aware that you can get the items out of an enumeration, and it's the type of whatever the name of the enumeration is. So then what I could do is it'll go through, it'll get the first name out of day, Sunday, sticks it into day with the lowercase d, and then it will console.writeLine whatever that value is. So it'll say Sunday. Then it goes back and it says, okay, get day is going to be the next element, Monday. So Monday goes into day, and then we print that out. So essentially what for each is doing is giving me just a temporary location where I can store the value that's in the array and then put that into some future line of code. All right, so that one would actually just simply display all of the days of the week one at a time. I have no control over how many it does. It will do every single one of them that exists in the enumeration. All right, so I want to start searching through our arrays. And what I can do is, let's say I have a list of orders and I want to see if a particular order number exists. Well, what I could do is I could have an array that holds all of the order numbers, and then I could search through it using either a for or a while loop, and it will allow me to see if that item actually exists in the list. All right, so I'm going to use a for statement first. This is actually the easier way to search for it. What we're going to do is we're going to search every single element. So essentially what I would do is I would ask the user, enter an order number. And then, so let's say they enter order number 103. Well then, what it will do is it will look at the first element in the array and see if that first element is 103. If it is, great. If not, then it's going to go to the second one and see if it's equal to that value. If it is, great. If not, it goes on to the next one. Okay, so there is a catch. When I do a for loop like this, if I don't force it to stop when it finds a particular value, it'll keep searching all of the values that are in the array. A short array, that's not really a problem, but if I have an array with thousands of values in it, that will cause the system to run really slow while it's performing the search. What I can do with this, though, is I can do what's called a parallel array. So I could have two arrays, one to hold the order number and one to hold the total price for the order. And then what I could do is I could look at the first array, the one with the order list, or the order numbers, and I could say, okay, well, I did find order number 103, and then I can look in the other array to find out what the price for that order was. Alright, so what we can do is we just simply state that we're going to start at 0. We're going to look at the first element, go all the way through the length of the array, and notice we're looking at while x is less than the length of the array, because if I did x equal or less than or equal to, then it would actually go to the very last element plus 1, because remember our length is always 1 higher than our last element. So whenever we evaluate our length, we always want to be less than or greater than, or the other option would be valid values.length minus 1, because we have to account for that last element being 1 less than the length. Alright, so what we're doing is we're saying if the item ordered is equal to some value in our array, then we're going to set some sort of flag to state that yeah, it was found, it's true, and then we're going to list the price because we know what element it was at. So we can actually look in another array. So if I find it at element number 3 in the order list, then I know that the price is going to be item number 3 in the price list, and it will allow me to do that. We can also do a while loop, and a while loop is going to be similar to the for loop. It's a little harder to set up, but what we actually get out of it is we have the ability to wait for other inputs. So maybe we want to keep searching through an array until some other event occurs. And so our while loop doesn't necessarily have to go through the entire array. We could say while we haven't found it, keep doing it. Or while the array length is less than something, then we can search it. So we have some more conditions that we can set with a while loop. A for loop, that's a definite loop. We're definitely going to start at 0. We're definitely going to go up to the max. We're going to search every single element. The while loop actually has some other options available to it. Alright, we can also perform what's called a range match. And a range match just simply means that I want to provide a discount based on how many things a person orders. So in this case, if they order anywhere from 1 to 12 items, they don't get a discount. If they order 13 to 49 items, they get a 10% discount. If they order 50 to 99, they get a 14% discount, and so forth. Well, the way that I'm going to do this is I'm going to create 2 parallel arrays. One is going to hold the minimum value that is required to get the discount, and then the other array is going to hold the actual discount. So what we'll have here is our discount range low limits. So that's the lowest number available in that range to get the discount. And so if I order anywhere from 1 to 12 items, I get no discount. If I order 13 to 49 items, I get a 10% discount. If I order 50 to 99 items, I get a 14% discount, and so forth. And what this allows me to do is I could say that if your value is greater than or equal to this low range limit and lower than the next number up, then we'll give you this discount. So I actually have the ability to perform searches and find out what kind of discount you get based on the elements that exist in these 2 arrays. Alright, so an array, like I said, it is an object, so I can manipulate it. And we have a system.array class that actually will allow us to perform other manipulations of our arrays. The most common ones that we're going to use are a binary search. And a binary search, what that will do is it'll allow me to search through the array to see if something exists. Now, in the for loop, we're looking at every single element, and we're going to compare some value to see if it exists, and then we have to find out what the location was. And what the binary search does is all I have to do is tell it the name of the array and what I'm trying to look for, and it will automatically find it for me. Now, the problem is that my array, for the binary search to work, has to be in ascending order, which means it has to go from the smallest to the largest. If it doesn't, it will actually error out when it gets to a number that's big and then a smaller number. The other problem is if my array holds more than one of the same value, then I can't use the binary search. I have to use a for loop. And then if I want to find a range match, I can't use this either. I have to do the for loop. So I'm only going to do the binary search if all of the elements in my array are in ascending order, I know there aren't any duplicates, and I know that they're all unique. We're not looking for a range. Okay, so our binary search method would look like this. So what we're going to do is we're going to assign some sort of variable to hold the location or what the element number is, the index for that particular element, and we're going to say array.binary search. We're going to tell it what array it is, so ID numbers is our array, comma, entry ID is what the user told it that they're looking for. So if we tell it, look at ID numbers and then 204, then what it will do is it'll go through the array and it'll say 122, no, that's not it. 167, no, that's not it. 204, that is it. Okay, so this is 0, 1, 2. So it'll take the index 2 and stick it into X. Now what we can do is we can turn around and say, we found it. So we found it at position X. And then it'll tell us exactly where it is in the array. Alright, so when they do a binary search, in this case, this one says ID 219 was found at position 3. ID number 220 wasn't found. So we can actually do that just simply by binary search. Now, all we're doing with the binary search is finding the location in the array. It's up to us to make a selection statement afterwards to decide what to do with that location that we received from the binary search. We can also sort it. So, like I said, the binary search requires my array to be in order. And so if I want it to be in ascending order, I can actually run a command that is array.sort, and what it will do is it will put my array in ascending order. So I could do an array.sort first and then do the binary search. Alright, so if I do a sort, it would be array.sort and then pass the name of the array. There's no setting it equal to anything. What we're doing is just simply telling it, sort this thing out. Alright, so if we sort it, then what it will do is it'll turn around and it will put all of the values that are in the array in ascending order, which means A to Z or 0 to whatever the largest number is. Now we can also do what's called a reverse, which means we could take whatever the order that the array is in right now and just simply reverse the entire order. We can do that by simply doing an array.reverse and pass in the name of the array. And what it would do is, in this case, we have Zach, Rose, Wendy, and Marcia. And if we do the reverse, it'll put it in Marcia, Wendy, Rose, Zach order. So you'll see here we have Marcia, Wendy, Rose, Zach. So we're just simply taking the order that the array is right now and just simply reversing it. Alright, so these type of arrays are called one-dimensional or single-dimensional arrays. And essentially what that means is that I am providing one value for each index element. So think of it as a column in a spreadsheet or something like that. So I'm just simply making one column worth of values and each line gets a value. But what I can do is I can also use what's called a multi-dimensional array. And what a multi-dimensional array does is allows me to have not necessarily just one column, but I could have multiple columns. So I could have 2 columns, 3 columns, and so forth. And so I could create what looks like a table. Now, to us, we expect a table to look like rows and columns. The system is going to require just a little bit different. But we also refer to these things as a rectangular array, a matrix, or a table. Alright, so this is what I expect a table to look like. So essentially what we're going to have is we have our first record, so our first element, and our first element has a second element, so it has the first column. So this would essentially be like our row value, and then this is our column value. So in this case, you'll notice everything in this row starts with 0, which means that these all belong together, and then the 0, 1, 2, 3 is going to be our rows. Alright, so let's say I have something where we have a list of apartments. And so we have, if you live on floor 0 and you have 0 bedrooms, then your rent is $400. So maybe this is a loft. Alright, so then if you're on floor 0 and you have 1 bedroom, then your rent is $450. And then if you're on floor 0 and you have 2 bedrooms, then the rent is $410. So, I'm sorry, $510. So what this allows us to do is it allows us to put all this information into one array. Because if I were to do this as single arrays, what I would have to do is I'd have to make one array to hold the floor. I'd have to make an array to hold if you have 0 bedrooms, another array to hold if you have 1 bedroom, and another array to hold if you have 2 bedrooms. And so what we'd have to do is we'd have to do a lookup where we'd have to say, okay, what is the location of the floor? And so if I told it floor 2, it would say, okay, that's location 0, 1, 2. Okay, so we're going to look at location 2 in the 1 bedroom array, and the value is this, which requires me to do a search, then to do a lookup to get this value. And instead of doing this, what I could actually do is just simply make a multi-dimensional array and I just simply locate 2, and once I find 2, then I can see the other values right along with it. I don't have to do the lookup. Alright, so when we actually declare our array, we're going to declare the data type, and we'll have the square brackets, but notice this time there's a comma in the middle. And what this tells it is that I'm passing to it a multi-dimensional array. And so what you'll notice here is that our array, before we had the curly brackets, meant that whatever was inside of it was an array, and each value was listed separated by a comma. Alright, so in this case, this whole thing is element 0. This whole thing is element 1. This whole thing is element 2. This whole thing is element 3. Within element 0, I have a sub-element of 0, a sub-element of 1, and a sub-element of 2. So this is 0, 0, 0, 1, 0, 2. Alright, this is element 1, so this is 1, 0, 1, 1, 1, 2. This is element 2, so this is 2, 0, 2, 1, 2, 2, and so forth. So I can identify all of these locations by simply performing a lookup, and my lookup is going to include all of the locations. So I'm going to tell it I'm looking for where anything that starts with a 0. So let's say I'm looking at all these rows. I'm looking for the one that says 625. Then once I locate that, then I can look at this row's 2-bedroom. And it allows me to actually do a lookup just one time, and then I can actually find the information that is associated with it in the same array. Alright, so in this case, enter the floor in which you want to live, 2, how many bedrooms, then you rent a 676. Alright, I can also use 3-dimensional arrays. And so essentially what this would be is, imagine in Excel. And inside of Excel, a 2-dimensional array would be what you're used to seeing as a spreadsheet. A 3-dimensional array would be, imagine in one of the cells in Excel that I were to put an array inside of that cell. And I could do a 1-dimensional array, I could do a 2-dimensional array, 3-dimensional array, all of that inside of one cell. And then we start getting into 3, 4, 5, however many dimensional arrays that we need, we can actually keep adding data. So when I add an array inside of that location, then inside of each of those I could have another array. Now we're not going to get that involved in it within this lesson, but at some later point you may need a 3 or 4-dimensional array to be able to perform a lookup. Alright, so we can also end up with what's called a jagged array. Now this is going to be a little different than a multi-dimensional array. This is where we are actually declaring multiple arrays based off of our original one, and each one has different values. Different number of values. Alright, so in this case we're creating a double, and you notice it has 2 brackets here. What this means is that this is a jagged array. Alright, so we're creating an array with other arrays inside of it. And so we're going to call it tickets, and the curly brackets here identify the beginning and the end. And we create a new double array, and this double array actually has values. The benefit of this is that this actually allows me to have however many values are here, but this one only has 2. This one has 6. This one has 5. This one has 2. So I can have multiple arrays all contained within one array, and each one of them has different sizes. Alright, so the problem is that we're going to start using our arrays when we get into GUI apps. And one of the things that we need to consider is that in a GUI application, our array has to exist outside of the method that runs when you click on a button. So essentially what we're going to do is we're going to create arrays as a global array variable location. So what you want to do is pay attention to where you declare it. Make sure that the array is not declared inside of the method that's used when you click on the button. Alright, so I've created a chapter 6 folder, and I have my template and my command with path. And so what I want to do is I'm going to create a copy of my template, and I'm going to call this one Pringle underscore week 7 underscore number 1. And what I want to do with this one is I'm going to start a little bit out of order from what you see in the book. What we're going to do is we're going to create a program that is going to allow us to read through an enumeration and do a for each. So I'm going to do this as an enum and for each. And so that my namespace is just simply the name of the program, but like you said before, it doesn't matter if you just leave it as program name or something like that, but when we start getting into bigger programs, we will need to change the namespace. So for this one, what I'm going to do is I want to create a new enumeration, and remember our enumeration has to be declared outside of our main method. So I'm going to make a new enumeration. I want it to contain fruit. Alright, so our new enumeration is going to have fruit objects in it. So we have an apple, a pear, banana, orange, grape, lemon, lime, and a cherry. Alright, so I have my enumeration just simply as with the fruit in it, and what I want to do is I want to list all of that out to the screen. Alright, so the way that we did this before is we did a for loop, and then we'd have to look at each enumeration element based on its index. Well, what I can actually do is I can use a for each. And so my for each command allows me to tell it what type of data type it is, so it's called a string. I'm going to produce or provide a name for our temporary variable, and in this case I'm going to call it fruit with a lowercase f. And I'm getting this out of an enumeration, so it's in an enumeration where we have to get the names of all the objects that are in it. And we are looking at something that is a type of, and it's a type of the enumeration called fruit. Alright, so I don't want you to necessarily be so concerned about what the naming convention and all the syntax of this is. Just be aware that you can do this. So what you need to be aware of is you're going to change fruit and fruit. This is the name of the enumeration. This is the variable name that I want to give to it. Alright, so then what I'm going to do is for each thing that's in here, we're going to write that out to the screen. Alright, so I want to write out fruit, and the question is which one do I use? This is the enumeration, this is the temporary location, and this is the one that will update every time it goes through the list. So that's the one that I want to use, the lowercase f. Alright, so I have my program, I save it, and then I need to compile it and then run it. Alright, so compile it. Alright, so now it's saying there's no overloaded method for getName, which means I misspelled it. It's getNames with an S. So now we compile it, and then I want to run it. So it's Pringle underscore, and here's my first program. And there we go. So what it did is it just went through the program or the enumeration, and one line at a time it got an item out of the enumeration and it lists each item individually. For the next program, we're going to copy our template again. And this is Pringle underscore week 7 underscore number 2. Alright, so this program, what I want to do with it is I want to start making an array, and then I want to be able to display the elements that are in it. So I'm going to declare array and display loop. Alright, so I'm just simply naming them so we get an idea of what each one's doing. Alright, so what I want to do is I want to make an array that just simply holds some integer values. So I'm going to say int, and then we do our open and close square brackets, and then my array is what I'm naming it, and it's going to be equal to something. Now I'm doing the shortcut method of actually initializing the array. So I'm going to say 1, 2, 6, 5, 3. Just making up some values for it. And so what I want to do is I want to display each of those out to the screen. Okay, so now my array, the system will automatically know that the size is 5, which means the length is 5. But remember, our last element is not element 5, it's going to be one less. This is element 4, so we have 0, 1, 2, 3, 4. So what I want to account for is I want to make sure that my loop will go through 0 through 4. So what I'm going to do is make a loop that's 4, and I'm going to initialize a counter called k, set it equal to 0 to start. And then while k is less than 4, then we're going to add 1 to k, so we're going to increment it. And then what I want to do is I want to write out to the screen whatever the element is. So we're going to say my array, which is k, and that's going to be our counter. And what this k is this is the subscript. So the first time we run through, k will be 0. Add 1 to it. The next time we run through, k is 1. add 1 to it, next time we run through k is 2, and so forth. So it keeps incrementing the counter, which means it'll keep looking at the next array element up. Alright, so now if I look at this again, watch our conditional statement here. While k is less than 4. Alright, the first time we run through is 0. That's 1 time through it. Next time we run through, k is 1. That's 2 times through it. Next time, k is 2. That's 3 times through it. Next time, k is 3, which is 4 times through it. Next time through, k is 5, which is 4, which is 5 times through it. So what we're trying to do is we're trying to make sure that our values here are correct. So the question is, should this be 4 or 5? All right, so let's save it and find out. So I'm going to run the program. Go here to my Explorer window, and I want to 7_n2. All right, so I run it, and now I want to actually run the program. All right, so now notice it goes 1, 2, 6, 5. Okay, so the question was it 4 or 5? Well, let's see, it was 5 actually, because we're doing less than. Now I could do less than or equal to, compile it and run it again, and now I get all of them. Or the other option is to say less than 5. So both of these will actually let me do the same thing. So they both work. All right, but I don't necessarily want to have to worry about what I'm trying to do here. I want to make sure that I'm going through 0 through whatever the end of the array is. So the end of the array is going to be the length. So I can do myArray.length, and this will actually allow it to do the same thing. So it'll be k is less than 5 because the length of the array is 5. All right, so if I save this, compile it, and then run it, I get the exact same thing. All right, so I want to show you how to resize the array. And what we're going to do is we're going to use a method called array.resize. Now, you're probably not going to use this for the exercises this week, but it's a good thing to know how to do. What we're going to do is we're going to send some arguments to a method called array.resize. And arguments will exist inside of our parentheses. So in this case, I have 2 arguments that I need to send to it. The first thing is the name of the array, and the second thing is going to be the new size. So I want to make the new size 6. All right, so if I do this, what will happen is the array.resize method will make an exact duplicate of my array and make that duplicate a size of 6. So what I need to do is I need to tell the system somehow not to create a duplicate of array, but instead I want it to modify the existing one. And so what we're going to do is we're going to use this keyword ref, and ref means reference. And what that tells it is, instead of making a new copy of my array, I want you to modify the exact memory location where my array is. We will get into using ref a lot more later when we start using methods, but just be aware that when I pass an argument using ref, I'm telling it modify my existing memory location. All right, so what we're going to do is I want to set the array size to 6, and then I want to try to put a new element there. So what I'm going to do is I'm going to say something like my array, and in this case my last element, the size is 6, my last element is going to be 1 less than that, so 5 is going to be equal to 23, just to have a larger number. Alright, so let's try this and see what happens. Okay, so we compiled, we run it, and now you'll see that our array actually has 6 elements and the last element is 23. So what this does for me is it allows me to resize the array, and then once I resize it, then I can add new items to it. If I don't resize it, I will actually get an out of bounds error and it will not let me do it. Alright, so what this is doing for me is it is creating the array with these 5 elements in it. We're going to create a 6th element location, then we're going to put that value of 23 into the 6th location. And then we read through the array from beginning to end and display it out to the screen. And the question is, what if I want to display this in reverse order? So what I want you to do is, this is saved currently as number 2. We're going to go to File, Save As, and we're going to make it number 3. So we're going to make a number 3.cs, which is an exact duplicate of number 2. And what I want to do is I want to start my counter at the length of the array minus 1. So whatever the length of the array is, because what I want to do is I want to count from 5 down to 0. The length of the array is 6, so I need to count from this last location. So we're going to start at 5 and then go down to location 0. So what I'm going to do is I'm going to say that k is equal to my array dot length, and then we're going to subtract 1. So what that does is the length is 6, subtract 1 gives us this highest memory location of 5, and then while k is greater than 0, then what we're going to do is we're going to decrement k. Alright, so this will count down through our array. So it creates the 6th memory location, puts 23 into it. The first time we run through, k is equal to 6 minus 1, so it'll be k is 5. We display location 5. The next time we run through, we decrement by 1, so now we have 5 minus 1, which is 4, so we display memory location 4 minus 1. So now we have 4 minus 1, which is 3, and so forth. Alright, so I want to compile it, and this one is number 3. So we compile number 3, and then we want to run number 3, and we'll get a reverse order. Alright, so the question is, why did it go down through 23, 3, 5, 6, 2, and it didn't skip the last one? And the question is, while k is greater than 0, so it'll only get to 1. It won't ever get to the 0. So what I have to do is I have to modify this to k greater than or equal to 0, compile it and run it, and now I will get my last one. So there is a little bit of difference between counting up or going through it in ascending order and looking at descending order. We have to modify our limits for our for loop. Alright, so the next program is going to be a new one, so let's go ahead and copy our template. And this one's going to be Pringle underscore week 7 underscore number 4. And this program, what we're going to do is we're going to create an array, and we're going to search the array and locate the position for a particular item. So search array and locate position. Alright, so what I want to do is I want to declare a new array. And so what I'm going to do is I'm going to make a new array called order list. And I'm going to just simply make some fake values up for our order. So 103, 203, 304, 406, 502, 607, 708, 801, and 903. So I'm just simply making up values for it. And so if you look at this, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in my array. So the length is 9, but this one is location number 8. Remember, our last location is always one less than the size of the array. Alright, so what I want to do is I want to ask the user to enter an order number. So I'm going to say console.write, as long as I don't misspell it, and I'm going to say something like enter order number. Okay, and then what we're going to do is we're going to make a new string value to hold the order number. So my new string value is going to be str order number, and I'm going to set that equal to whatever they wrote in. So I'm going to do a console.writeLine, read line. And so whatever they typed on the line, put that into str order number. Now I don't need to convert because this is a text string and this is a text string, so there's no conversion here. Alright, so what we're doing is we're asking them to enter a number, say 304, and I want to see if it exists in the list. And so what they're going to do is they're going to enter a number, and if they enter 304, we're going to compare that to this first number. Is that 304? No. Is the next one 304? No. Is the next one 304? Yes. Okay, so there are a couple of things I need to do. One is I need some sort of flag to state, yes, we did find it. And I need a value to hold its location. Remember, we're going to use a register to temporarily hold a value. So I'm going to create a variable location to tell me that I have it and where it's located. Alright, so I need some variables to do that. So I'm going to create a new string variable, and I'm going to call it strisFound. and I'm going to give it an initial value of no, or n. And I also need a value to hold where this value is actually found. So I'm going to make a new integer location, because remember, our indexes are integers. So this is int item location. And when we start off, we have to give this a value, or else our program will not allow us to perform an evaluation later. So I'm just simply going to give it an initial value. All right, so the question is, if I set this at 0 and something happens later in my program, is there a possibility of this one giving 103 to me? And the answer is yes. So instead of using 0, maybe I want to make it invalid data like -1. And then what that does is it'll make it where if for some reason it doesn't find it in here, this is an invalid piece of information, and we won't accidentally give somebody back 103. All right, so what we're going to do is we're going to perform a for loop to locate the value in that array. Okay, so what we're going to do is we're going to make a counter, and we're going to call it k, and k is going to start at 0. And while k is less than order list dot length, so anywhere from 0 through 9, actually technically 8 because we're 1 less than that, and then what we're going to do is increment k. So this is our counter, this is our typical for loop. Alright, so what we're doing is we're going to tell it that for each time it goes through here, we want it to look at each array element and see if it's the same number. So what I'm going to do is I'm going to say if str order number is equal to order list k, then I want to do two things. One is I want to set str is found to yes, and I want to set int item location equal to whatever the location is. Well, we will know the location because k is our counter is keeping track of where this is right now. So what I'm going to do is I'm going to say str is found, and we're going to set that equal to y. And then the next thing is that we're going to say int item location is equal to k. Now, I could have made this a while loop, and I could say while str is found is equal to no, or that k is less than the length. So I could go a little more fancy than this and make it where it would automatically stop searching, but for this case we're just going to let it search, which means this one will check every single one of them even if it does find the number. So if I type in 203, it gets here to 203, it'll still compare the rest of these. This would not work if there were duplicates. Alright, so what we're doing is we're going to go through the array one item at a time, check to see if the number that the user entered is equal to the number that is in here, and then we're going to, if it is, we're going to set str is found to yes, and we're going to set the item location to k so we know where it is in the array. Alright, so there's a problem here though, is order list k is referencing an integer value. And so even though order list is an array, it has a data type of an integer. So what I have to do is I have to convert this thing to a text string to be able to compare them. So what I'm going to do is I'm going to say convert .toString, and what are we converting? We're converting order list. Okay, so for me to be able to do that search and do this comparison, I have to convert this one to a string, or I could convert this one to a number. Either way would work. Alright, so what we're going to do is we're going to run this, and then when we run it, we want it to tell us where it is, if it's found or not. So we're going to have one more if statement. We're going to say if str is found is equal to yes. This means that it found it. Then what we're going to do is we're going to write out on the screen that it was found. So I'm going to say console.writeLine, and I will say something like the item was found. Okay, but now I can also tell you where exactly in the array it was found. So I can say at array location, and we'll set item 0. And what is item 0? Item 0 was int item location. Okay, but if it's not found, then we're going to tell the person that it's not found. So we'll say console.writeLine, the item is not found. Semicolons. Alright, so anyhow, we're going to search through the array, see if we find it. If we find it, we set str found to yes. If str is found as yes, then we display the location. If it's not, then we just simply tell you it's not found. All right, so let's try to run this. Seven, 4. All right, so on line 12, I'm missing a semicolon right here. All right, so now we have our program is compiled, so program underscore week 7 underscore number 4, and then we run. Okay, so now I want an order number that's here in the list, so I'm going to do 304. And so it tells me the item was found at array location 2, 304. That's the third item in the list. Why does it say number 2? Well, remember, it's 0, 1, and 2 is our index number. So we always have to account for our index number being 1 off. All right, so let's try it again, and this time I'm going to enter number 980. That item is not found. So what it's doing is it's allowing me to see if it exists, and if it does exist, then I can tell you exactly where it is in that list. All right, so that was for number 4. I want to make a duplicate of this for number 5, so I'm going to do a save as, and we're going to call it number 5. So now it's exact duplicate. All right, so what I want to do now is I want to make it where we have these order lists, but we also want to be able to keep track of the price for each of these orders. All right, so we're keeping track of the order total price. So I'm going to make a new array that is a double data type, and I'm going to call it order total price, and I'm going to set that equal to some prices. So we have 23, 94, and we have 9 orders, so I need to have 9 different prices down here. So 34.95, 54.12, 36.21, 15.21. Just making up numbers here. So I have 1, 2, 3, 4, 5, 6. Need 3 more. Okay, so now I have my total. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so 9 orders, 9 prices. So now what I can do is I can look at this and I can say, okay, order number 304 is the third element in here, but it's actually index number 2. Well, what I can do is I can associate that with index 0, 1, 2. Here is the price for that order. So now what I could do is I can modify my output here, and I could say something like the item was found at array location 0, and the total is, and this is going to be 1. And so what is 1? Well, 1 is going to be our order total price, K. I'm sorry, not K, but in item location. So what I can do is I can do order total price, and then in brackets I'm going to do int item location. And then so what this will do is it'll look at it and say, okay, the item location was 2, so order total price 2 is 54.12, and it'll give that price to me. All right, so I want to compile this. This is number 5. And we want to run number 5. Okay, so now 304 is our order number. It says the item was found at array location 2 and the total is 54.12. So I have these 2 parallel arrays, and by setting them as parallel arrays, now what I can do is I can look for the item here, and once I find the item exists, then I can look in the corresponding array and give the exact price for it. In this lesson, you learned that an array is a list of data items. All of the data items have to have the same data type, and they're all going to be referenced by the same name. But the only thing that distinguishes them is their subscript or their index. In C#, arrays are objects of a class named system.array, which means that we have a lot of functions that we can perform on them that are built into the system. You can use the arrays to start using the subscripts, and it allows us to do loops to be able to perform functions on the array. Remember that the subscript begins at 0, and the last element is always going to be the length of the array minus 1. We can use the for each statement to go through the entire array one element at a time to see if a particular item exists. We can compare the variable that is created by that for each to a list of values, or I could also create a variable location. I can ask a user to input a number and then go through the array to see if it matches any of the elements in the array. We can create parallel arrays to be able to do our range matches, or also to be able to associate things like our order list with their prices. We can do binary searches, which would do the exact same thing. It would allow us to search through the array to find a particular element and get its location. And we can also sort our arrays. And when we sort them, it puts them in ascending order. If you reverse the array, it takes whatever the order is currently of the array and just simply gives it back to you in the reverse. We can use multidimensional arrays. Make sure that you're aware that when you have a multidimensional array that you account for how many dimensions it is. So our array index is going to be something comma something, like 0 comma 1. And then we have two-dimensional arrays, which are considered to be our rectangular arrays. Our three-dimensional arrays, which is where we have an array inside of another array. And then we also have jagged arrays, which allows us to put an array inside of another array element. And then each of those elements can actually have different array lengths.